Hi everyone, we've seen molarity. We know that molarity is moles of whatever solute we have over liters, and that's all well and good as long as we're dealing with a solid solute. But what if we have something that we need a certain concentration of and it's already a solution? So acids are a really good example of a compound that we use often in chemistry that pretty much only exist as solutions. And so we can't very well just figure out the number of moles we have over a certain volume, because we're not starting with a volume of 0, and we're also not starting with a mass. We're starting with really an amount that's dissolved already. So in this case, we have to do a dilution. We have to take a solution and we need to change its concentration by adding more solvent. And in our case, the solvent we pretty much always will use will be water. And so we'll do this using an equation that looks extremely like Boyles Law. And we're going to say that the left-hand side of this is going to be the solution concentration that we want at the end of the day. So we'll call this desired. That's what we ultimately want. And then what we start with, we are going to call this the stock solution. The stock solution is what concentration the acid starts at, basically what it comes off the shelf as. So let's see if we can define M1, V1, M2, and V2 for different problems. Looking at number 1, we're told some information about the stock solution. We're told it is 17.5 molar. And we're also told some information about the acid that we want to make. We want 500 milliliters, that's a volume, of 1.000 molar. So we can define our M1, V1, M2, and V2. Our M1, that is our desired molarity, is 1.00 molar. We want to make 500 milliliters of that concentration. Our M2, that's the molarity of our stock solution, is 17.5 molar. You'll notice it's a really concentrated acid to start with, and we want to know basically how much of that we need to use. So if we go ahead and we look at our equation, which is M1V1 equals M2V2, we ultimately want to solve this thing for V2. And so to do that, we'll need to divide off M2 from both sides. So we'll get M1V1 over M2. If we plug in all of our variables, let me just erase that. Let's go ahead and plug in all of our variables over here. So we'll say that V2 is equal to that M1, which was 1.00 molar, times that V1, which was 500 milliliters. And we're going to put that over our second molarity. In this case, it's 17.5. That was that stock solution molarity. If you go ahead and you crunch the numbers here, you're going to notice that your molarities will cancel, M over M. You're left with milliliters in terms of your unit. That's good, and it turns out that it is 28.6 of those milliliters. So what does that mean? What does that number mean? Well, that means if you want to make 500 milliliters, let me get a new color here. If you want to make 500 milliliters of this acid, and you want to have a concentration of 1 mole per liter, that means that you need to take 28.6 milliliters of the initial 17.5 molar stock acid, and then what do you do to it, right? Like you have 28.6 milliliters, we ultimately want 500. Well, what we'd want to do is dilute the rest with water. So you take 28.6 milliliters of your stock solution, and then you fill it up in a graduated cylinder, or even better, we have these things called volumetric flasks that we'll use in lab, and we'll get the total volume of the solution all the way up to 500 milliliters total. So we'll have 28.6 milliliters coming from that initial acid, the rest is water, and that will give us a final molarity of 1 mole per liter. So let's try it again with some other examples. If you look down to number 2, we're going to see what molarity of this sulfuric acid we need, what volume of that sulfuric acid we need to make a new 0.1 molar, and we need 1.5 liters of that new solution. So again, let's define variables. Our M1, that is our desired molarity, is 0.10 molar. We ultimately, at the end of the day, want 1.5 liters of that solution, so 1.5 liters. Our M2, that's the molarity that we're starting with, is 16 moles per liter. And our V2 is what we're trying to find. How much of that do we need to add in and then dilute? So again, we're going to solve our M1 V1 equals M2 V2 for V2. So we'll divide out M2 from both sides, M1 V1 over M2. We'll come on over here, we'll plug in everything that we have. So we have, at the end of the day, V2 equal to our desired molarity, which is 0.10 molar, times the volume that we're after, which is 1.5 liters, over the molarity that we're starting with, which is 16 moles per liter. And if we solve that, again, notice that your molarity cancels. That's good. We'll be left with milliliters. In this case, it's going to be, we'll be left with liters. In this case, it's going to be 0.0094 liters. And we can leave it at that because the question only asks for a volume. In practice, if we were actually doing this in lab, it's really hard to measure out 0.0094 of something. So probably we'd want to come through and we'd want to say, well, we know that 1 liter has 1,000 milliliters. And so if we go ahead and we do that multiplication, we will be left with 9.4 milliliters. Again, you don't have to do that extra step if you're not doing this in lab because the question only asks you for volume. And once we've reported in liters, we're in a volume, so we're good to go. But in practice, in lab, we'd probably actually want to go to milliliters, so this becomes easier to measure. Let's try one more. This would be a great time to go ahead and pause the video if you want to and try number 3 on your own, and then you can come back for the answer. So if you've paused and you've tried number 3, let's get right into defining our variables. Hopefully you recognized that your desired solution, your M1, has a molarity of 0.25 molar. Your V1, you're finishing with 0.75 liters. The molarity of your stock solution is 12 moles per liter, and the volume is what we are trying to find. So again, we have M1 V1 equals M2 V2. We're solving for V2. We'll have M1 V1 over M2. We're going to plug everything in, so we'll get V2 is equal to that molarity that we're after, which is 0.25 molar, times 0.75 liters, that's the volume that we'd like, over the concentration of our stock solution, which is 12 moles per liter. That gives us a volume of 0.016 liters. Again, that's hard to actually measure out in lab, so if you multiply that by 1,000, this turns into 16 milliliters. And that is the volume of that stock solution that we want, and then we'll dilute the rest with acid. We'll dilute the rest with water, sorry. One thing we didn't talk about is sig figs. You'll notice these are just multiplication division problems, so really all we care about is the least number of sig figs. In all of our problems here on the bottom, there were 2 sig figs, and in the top problem number 1, there were 3 sig figs.